All right, so tomorrow you have the first half of your retake. So, sorry. The retake this semester is going to look more like the ones that you would have had in Algebra 1 and Geometry, where it's not broken down into individual pieces. It's just, think of it as one big retake that is just, you're taking it over 2 days. You're taking it over a 2-day span. In total, how many questions will you get? 30. So you will get 1 grade as a big 30-question quiz, which is actually helping you get ready for midterm, which will be next Tuesday. It's midterm in the lab. Now, in addition to that one big quiz, those 30 questions are specifically aligned to have 10 questions corresponding to each of the tests that you've already taken. You know where I'm going. Must save spot in book. And I mean, practically speaking, it's extra credit. That's the way extra credit works, right? That your grade can only go up, it can't go down. So individually on those 10 questions that correlate to the test, if you do better than you did the first time, then it swaps it out. You know, but that for just the test, the original quiz grades are that the original test replaced the quiz, but that's it. Now those quizzes are locked. Those quizzes aren't going anywhere. But now the original test can be replaced by the one that we do. It doesn't double dip. But it's better for you because the tests are worth more than quizzes. So yeah. So is learning things the first time around. But I guess you need a better teacher for that. So tomorrow is where we take that first half, the first 15 questions. So you'll get 10 questions tomorrow from test 1 and 5 questions from test 2. Then Monday will be the other 5 questions from test 2 and 10 questions from test 3. That'll be on Monday. Thursday, I don't see you at all. You'll be with your first period the whole time. I won't see you Thursday. Friday, I won't see you either because you're getting the day off. And then Monday, we're back at it. So, any questions? Lauren, you feel okay today? Kind of. Sort of, maybe, but not really. All right, so here we go. Let's look at the first one. Let's graph the following function and indicate all the key features. What type of function do we have here on number 1? Exponential, good. Everything that we're about to fill in will then rely on the base. If you wanted to be more specific, you could say that's an exponential decay, but then also the transformation values. What is A here? -2. What is C here? What's H? -3. What's K? Again? Okay, we'll do the same thing again. We're gonna get to know each other very well. Here, I'll hold it for you. I'll hold it for you. Yeah, because you can't be trusted. You can't be trusted. It goes there. I'll hold it for you, and you get it back at the end of the class. Thank you. And we'll schedule one of our appointments. Whether you are graphing quadratics, radicals, exponentials, logs, it doesn't matter what's here. Once you know this, now you can always answer this when they ask you to list the transformations. Doesn't matter what you're transforming; those values are always going to do the same thing. So let's see if we know how to interpret those. Camila, what's the A going to do? Very good. It's negative. So we're going to have an x-axis reflection. That's the first thing. Is it going to do anything else? She did so well. Let her do the rest of A. No, that's it. Caroline? It's going to do a vertical stretch of 2. Okay, and that takes care of A. Jonathan, is C going to do anything? No. How about H? Yeah, translate 3 units left. This is a little bit misleading because you see these 3 bullet points and you think that there was only going to be 3 transformations, but no, because Caleb, what's the last one? Good man. Translate 5 units down. Okay. Now, once we get into graphing, now this becomes more important because we're going to have to use parent points and transform them. We will answer the majority of the questions to the right after the graph, but let's see if there's any that we can answer right now, at least easily. You can probably answer most of these right now, but at least the easy ones. What do we know about all exponential functions? The domain is all real numbers. Just by knowing it's exponential, that's locked in. Just because I already drew it and I haven't deleted it, it's already there. Where do you find the asymptote? Thank you. It's horizontal. Anytime it's horizontal, I know it's going to start off with y equals, and it's supposed to be at y equals k. And what's the k value here? -5. That's what you already see there. And a lot of that other stuff you could answer without the graph. Definitely the intercepts. The intercepts we always found algebraically. But let's just go ahead and graph this now, and then we'll answer the rest of it afterwards, since we have to graph anyways. All right. The parent points, okay, the starting points before they enter the transformation portal, are based on the base. What is the base of this exponential function? 1/2. Okay, that's the base. So what I'm going to do is whatever I pick for my x's, I can pick whatever x's I want. I have a domain. Jeez, this thing moved again. Son of a... I have a domain that's all real numbers. I can pick whatever x's I want to take 1/2 power to those to take 1/2 to those powers. What did I recommend when you have a base that's a proper fraction? To pick 0 and negative. Okay. But now I cheated a little bit because I've already done this one. But let's just now see the purpose for this, because it's not that you can't pick positives. But typically on those, on the decays, if you pick positives, the numbers are going to be so bunched together that you're not going to see the curve well. So yeah, these are definitely numbers I would pick, but watch, we'll see what happens. What's 1/2 to the 0 power? What's anything to the 0 power? 1. Okay, why do we pick negatives? Well, what's the negative going to do to the base? It's not going to make it positive. It already is positive. Well, what's the negative going to do to the base? Well, it's going to flip it. It's going to flip it. And it's not always a whole number, but it's going to give me the reciprocal, which here it is. All right, here, let me write it nice and big. You don't have to write it as big, but just like for this next one, if I take 1/2 to the -1 power, that is the same thing as taking 2 to the +1 power, because this negative gets this 1/2 and it flips it. The reciprocal of 1/2 is 2. So now that you can see this, you can kind of translate it to the rest of them. What is 1/2 to the -1 power? 2. What's 1/2 to the -2 power? 4. What's 1/2 to the -3 power? 8. So the first time I did this, I was all excited. Hey, these points they work out really nice. But now look at what happens when we bring in the transformations. For the x's, all I want to do is take away 3. For the y's, I want to multiply times -2, and then I want to take away 5. So I started to do this. I was like, all right, look, the x's work out nice. -3, -4, -5, -6. So far, so good. But then with the y's, -2 times 1 is -2 minus 5 is -7. This gives you -9. Oh, man. Look at the 4. That's going to give me negative 13. Look at the 8. That's going to give me negative 21. What's the problem with those? It doesn't fit in the window. So you have a couple of options. You can rescale, but on these tests, these are, especially, I mean, tomorrow it's going to be multiple choice. You're not going to be the one physically graphing. You're just going to have to rely on what's there. And the ones on test, they're not really meant to be changed. So what I decided to do then the first time I did it, say, all right, well, you know what? Let's go where we say we wouldn't go. Because what ends up happening is that, like, the points themselves are not the issue. It's that stretch is what's causing it to jump outside the window. So to try to get it to fit in the window that we already have, let's go to, you can pick whatever x's you want. I was just trying to not have the points be too bunched together, but let's go the other way. If I were to go to the positive side, let's try positive 1 and positive 2. What is 1/2 to the positive 1 power? It's 1/2. What's 1/2 to the positive 2 power? 1/4. Okay, well, on the x side, not a big deal. 1 minus 3 is negative 2. 2 minus 3 is negative 1. And on the first one, it works out pretty nicely because what is negative 2 times 1/2? Negative 1. Negative 2 times 1/2 is negative 1, minus 5 is negative 6. Then on this last one, I'm going to get a little bit of a fraction, which I guess you can turn to a decimal because there's no rounding. What's negative 2 times 1/4 times 1/4? It is negative 1/2. You can also put negative 0.5. That might help some of you. So you end up here with, let's just say, negative 5.5. Let's keep it, because if I put it as a fraction, everybody will be confused. So let's just put negative 5.5. So these are the points I want to end up graphing. Negative 3, negative 7. Negative 4, negative 9. And you see this is where we were going to jump outside the window, so we went back to negative 2, negative 6, and negative 1, negative 5.5. There's my little curvy curve. Whoa, that's weird, Mr. Romero. Why is that below the asymptote? There was an x-axis reflection. We knew that was going to happen. Let's see if we can answer the rest of the questions now. We could have already answered this before because we knew that an x-axis reflection was there, but now it's easier because we see it. What's the range? Jonathan, you give me the range. Au contraire. Range. How low and how high? Does not go up forever. Negative infinity is how low it goes. Up until negative 5, yep. Oops, and it just got cut off. The asymptote was at y equals negative 5. Jonathan, I'll stay with you because I remember these gave you trouble before. Is this increasing or decreasing? This is increasing. If this were a roller coaster, I'd be going up. And because this does not change direction, we don't see this graph doing this. It's not changing up and down. It's starting to really flatten out, and after a while, it's going to be a really boring roller coaster. But it will always go up. It's infinitely going up towards that asymptote. It's just not reaching it. So whatever the domain was, you just repeat it. It's increasing through all real numbers. The x-intercept, we can tell by looking at it. We're still going to prove it algebraically, but we can tell by looking at it. Where's the x-intercept? Yeah, there isn't. It's not touching the x-axis. Should be pretty obvious, but we're gonna prove it algebraically. And as far as the y-intercept goes, it looks like it's doing it just underneath negative 5. I don't know where. We'll find it algebraically. I don't know where. Let's jump to end behavior, and then we'll go back and do intercepts. What is the left arrow doing? The left arrow for x is going to negative infinity. And as x is going to negative infinity, what's y doing? Also negative infinity. What's the right arrow doing? It's going to positive infinity and negative 5. I don't know how. This is not going to guarantee you the right answer, but it can help you check it. Okay, we talked about this before. Where else do you see these four values? The domain and range. If you look at the x's, that's on the domain. If you look at the y's, that's on the range. Where the thing comes in is that you have to make sure you match them up correctly. You got to know which x goes with which y, what x goes with which y. But at least you shouldn't be just throwing some wild things out there. Hopefully you don't have to guess, but if you were to guess, hopefully it'd be an educated guess. Right, Soph? Are you writing a love note to your phone? Dear iPhone, how I miss you so. Allow me to count the ways. 1, 2, 3, 4, 5, 6, 7, 8. Let's find the intercepts. How do you find any x-intercept on any function that ever existed? Put in a 0 for y. Now we can tell from the graph what should end up happening here. Yeah, we should end up with an error. Was that Landon? Nice. What am I doing there? Ugly. What am I doing first? If I want to solve for x. Thank you. Look at Yash. Take that, Juan. While Juan is sleeping, Yash is working hard. Sid, next. Good. And I don't really like decimals, but we'll just stick with decimals here. So that gives you negative 2.5. At least you don't have to round. Is equal to 1/2 to the x plus 3. And then log base 1/2, and that's where the caca hits the fan. When you take log base 1/2 on both sides, if you take any type of a log of a negative, what happens? Error, error, error. So there is no x-intercept. Just proved it algebraically. Now, of the two, most people will find that the y-intercept is the more convenient one because the variable that you're looking for is already going to be isolated. How do you find y-intercept? Okay. Plug in 0 for x. So we go right back up to the function and say now y equals negative 2 times 1/2 to the 0 plus 3 minus 5. 0 plus 3 is 3. So negative 2 to the 1/2 to the third minus 5. 1/2 to the third is 1/8. Somebody impress me with your math skills and tell me that you know what's negative 2 times 1/8. What happens when you multiply negative 2 times 1 over 8? It is negative 1/4. Did you use the calculator for that? So it's negative 1/4 minus 5. This, now a lot of you have the fancy calculators with the math print that does this for you, or maybe you've already discovered that button that converts fractions to decimals and stuff. But you'd probably put here it's a negative 5.25. Negative 1/4 minus 5 is negative 5.25. So the x-intercept does not exist, not applicable, and y-intercept is 0, negative 5.25, and that's also consistent with my graph because I knew it was going to cross just below the 5 somewhere. The negative 5, sorry. Don't worry about it, Julian. It's going to be on YouTube later. And find a nice young lady and invite her to Romero Flicks and chill, and while you study. Good. What? I know that was long, right? We're gonna do another long one too now. These will be the only two long ones we do today, and then they'll get shorter. Let's do another graph. But now what are we graphing? A log. Okay. Well, what's the main difference with a log? There's more similarities than there are differences. Okay, we have a vertical asymptote, so let's just go ahead and here, let's name A, C, H, N. Okay. Where's A at? Or what is A? -1. What's C? Yeah, and anytime that -1 is there, you gotta factor it out. So that becomes x minus 4 in the parentheses. So yeah, C is -1, but then what does H become? +4. Good. And then K is your -3. So that vertical asymptote that you were talking about, where's it going to be? It's going to definitely be at x equals something, and it's supposed to be at x equals h. What's h? 4. If this is somewhere where you could get it wrong, because if you didn't factor out that negative, you would have put -4. Shame on you. What else do we know about all logarithmic functions? The range is going to be all real numbers. El rango. Juan, would you like a pillow? It'd be nice. You can bring like a puffy sweater, and you can use that. Maybe Julian will lend you his. Okay, good. Let's list the transformations. Regardless of what function is up there, the transformations they're gonna always do the same thing. Camila, what's A doing? A always does the same thing. A is negative. The same thing you got right before. X-axis reflection. Guess what? Here Y is also negative. C is also negative. So we're gonna have a Y-axis reflection too. And then Edvin, I'll give you the easy ones. What are the last transformations we have here? Good. Translate 4 units. Right, and what else? Translate 3 units down. Sophie, 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 Sophie. Okay. We could answer some of the stuff on the right if we wanted to, and actually later on in this we will answer some of those questions without the graph. But let's just graph this first. The parent points, the starting points, depend on the base. This base is 2, which is greater than 1. So what numbers did I recommend? 0 and positives. But what trick did I show you? Because this is a log, what should you do with that 0 and positives? Put them on the y. Yeah, the y here is the range is what has unlimited options. So we're going to put 0, 1, 2. We would like 4 points ideally. 3 could work, but 4 is the ideal number. And then to get the x's to start with, we're going to take this base to those powers. What is 2 to the 0 power? So put that with the first x. What's 2 to the first? What's 2 squared? What's 2 to the third? So let's take these numbers and transform them. For the x's, we need to multiply them by -1 and then add 4. The way you would write that is -x plus 4. The negative just means multiply it times -1. For the y's, I want to also multiply by -1, but then take away 3. So -y minus 3. So for the x's, negative 1 plus 4 is 3, 2, 0, and negative 8 plus 4 is negative 4. All I did was I made the numbers all the way over here negative, and then added 4. For the y's, I also want to make those numbers negative, but then take away 3. So this would be negative 3, negative 4, negative 5, negative 6. And these are the points that I'm going to end up graphing. You okay, Josh? 3, negative 3. 2, negative 4. 0, negative 5. Negative 4, negative 6. So you now with that last point, you really start to see the curve. You could have. It looks like you might have even been able to fit another point there. Oh wait, ugh, yuck! Cross the asymptote. I don't want that. So it looks something like that. If you're wondering, like Juan is, hey, geez, that's weird. How did I get that shape? Well, we know that any log that has a base greater than 1 should look like this. And since this underwent both reflections, let's use the wonder of technology to say, hey, if I were to get this basic shape and flip it over the x, and then flip it again over the y, that's where we get that basic shape. Now that we know what the graph looks like, let's go back and answer the rest of the questions. Let's go to Ali. Ali, what's the domain? Good. We are going to negative infinity to the left. Up until 4. Very good. Zeke didn't believe that you knew that, but take that, Zeke. Jenny Fan, how about my interval? Or first of all, am I increasing or decreasing here? Yeah, this were a roller coaster. It'd be a really fun one because you'd be going up and you'd be almost vertical. So this is always increasing, and it's going to be increasing throughout. Whatever the domain is, you just repeat that. The x-intercept and the y-intercept we'll find algebraically. Now, what we can confirm from the graph is that they both exist. We are both crossing the x and the y, and really, the y we already know. But we'll just confirm it algebraically. Jonathan, let's do end behavior. What's the left arrow doing? Negative infinity for x, and then what's the y doing? Also negative infinity. What's the right arrow doing for x? Good, yeah, we're only going as far left as 4, and then what's y doing? Facts. And notice how these 4 values match those 4 values. The 2 domains are what go where the x's go. The 2 ranges go where the y's go. He's got to know which one goes with which. Let's do those intercepts. How do you find the next intercept? Put a 0 for y. 0 equals negative log base 2 of negative x plus 4 minus 3. Tommy boy, what do I do first? Yeah, I've had better. You want Lydia to help you? Yeah, sure. Lydia, can you help Tommy know what to do first? Solve for x. Go ahead, Caleb. Yeah, let's get rid of this 3 out here. Let's add it. So 3 equals negative log base 2 of negative x plus 4. And then, good. We got to get rid of that negative in front. If we multiply by -1, that knocks out that negative. Do it here too. So -3 is equal to log base 2 of -x plus 4. What those first two steps have done, Thomas, is they've isolated the log. Now that the log has been isolated, it can be removed. And how do we remove logs? Exponential. So we get 2 as the base, so the -3 is equal to -x plus 4. 2 to the -3. What that negative is going to do is flip the base. That gives you 1/8, like Koa is saying over there. -4 minus 4. You could leave it as a fraction if you want, but since this is a graph is a type of measurement, you might want decimals. This should give you a -3.875 is equal to -x. So therefore, positive 3.875 gives you x. And if you want to go confirm with the graph that your graph is accurate, it does seem to be crossing the x-axis just inside of the 4. So that seems to make sense. The y-intercept is probably the easier one because now what you're looking for has already been isolated. So y is equal to negative log base 2 plus we already know what should we end up with here based on what we saw on the graph. We should end up with a -5. So let's see. -0 is just the same thing as 0. What is log base 2 of 4? Because order of operations, log comes next. It's on the same level as exponent. 2. So we just end up with -2 minus 3, which is -5. So my two intercepts for Yash are 3.875, 0, and 0, -5. So if I graphed one exponential, I graphed one log for you. The only thing that could be slightly different is that the exponential could have a base of e, and the logarithm could have an ln. And the only thing really different there is that to come up with parent points and stuff, you're going to need a calculator more. If I had a 2-hour period, I would do a couple of those also, but I figure our time is better invested going over these types, which deal more with characteristics. Now, I will say that the questions are pretty bad. So, I didn't write this, but let's scratch this word out here and put stretch because it's going to confuse people. Let's go to this next one here and add the word vertical in front and change this to a 1/5. Because if not, people are going to get confused. Sophie's confused. Write a logarithmic function with a translation that is to the right 4 units and a reflection over the y-axis, down 3, and a vertical stretch of 3/2. So this is going to depend on A, C, H, and K. What's A here? Nope. What's A here? 3/2. There's no negative. Nowhere does it say x-axis reflection. What's C here? -1 because there's a y-axis reflection. What's H? Yep, we're going to the right 4. And what's K? We're going down 3. Very good, -3. Now, it does not tell us what base to make the log, so you can make it whatever base you want. I'll just leave it base 10. Let's call this f of x. So f of x is equal to A comes first, it's 3/2. Then I'll just write log. Now, every log already has to have a parentheses. Okay, when you're doing logs, unless they're just like constants, like you're supposed to put a parentheses when there's a variable there, especially if there's more than one term. So I'm going to put a bracket first so I can fit in the negative from the C. Then I'll put the parentheses that always goes with the log. And what's going to go inside that parentheses? Not x plus 4. Yeah, if h is a positive, then I would put x minus 4 close close, and then minus 3. To which somebody always asks me, oh, Mr. Romero, but can we distribute the negative? Sure. So if you don't want to write it with those two parentheses, then you could just have a single parentheses and write negative x plus 4. Any of those would be correct. But it has to look one of those two ways. Okay, write an exponential function with a compression of 5 and a translation of 5. So A, C, H, K. What's A? 1 over 5. Good. What's C? Just 1. What's H? 0. What's K? Excelente. Zeke, we're going to call this G of X, just to give it a name. What's going to come first after the equal sign, Zeke? Good guess, Zeke. 1 over 5. Okay, this is exponential. They do not tell us what to make the base, so you can make. Don't get confused by this. Take whatever you want. What do you want, Hannah? No, why you get I don't mind it, but no, look, I don't mind it, right? But then there's people that are half paying attention right now and half somewhere else, and I'm gonna write an E, and well, but I don't get it. Where do you get the E's from? Do I make them all E? If you want to put E, that's fine. But let's just do this much more common, and let's just put a 2. But yes, you could put an E if you wanted to. There's no H, so all I need on the exponent is just the X, and then the plus 5 comes afterwards. Okay, number 10, a natural log. What does natural log mean? Yeah, so now we're going to do like the first one, but instead of log, we'll write ln. Let's identify A, C, H, and K. What's A here? -1. If we reflect over the x-axis, it's just a -1. There's no stretch or compress. C is 1. What's H? +6. And what's K? Sweet. Kendall, you got that? So h of x is equal to, A comes first. I need the negative. I don't need the 1. What's going to come after the negative, Zeke? You weren't paying attention. We just said it. Jenny knows. ln. That doesn't say in or 1n. That says ln. Parentheses. There's a parentheses that always goes with the log. X minus 6 and then plus 2. Now let's just knock out this last page. The domain of a logarithmic function is -8 to infinity. What is the domain and range of the inverse function? What is the inverse of a logarithmic function? An exponential, right? So now if we're talking about the logarithmic, right? Fine, they're giving us the domain of this, but what's the range of any logarithmic function? All real numbers, right? So what do we do for our answer, for what they're asking us for the exponential? Just switch the two. So now the domain of the exponential would be all real numbers, and the range would be, well, I don't even know how to write h. No, actually, no, never mind. I didn't need to write it. Sorry. -8 until, there you go. What is the domain, the range, and the end behavior of that function? What type of function is that? Exponential. What do I know about the domain of every exponential function? The domain is all real numbers. What is the range going to depend on? It's going to depend on the asymptote. Exponentials have a horizontal asymptote. If no flips occur, be more specific, if no x-axis reflection occurs, we're going to stay above the asymptote. The only way to get below it for the range would be if we did an x-axis reflection. Do we have an x-axis reflection there? No. Yes, I see there's a y, but the y is going to keep us above. So my range would be above the asymptote. It's at y equals k. So we're going to go from 7 up until positive infinity. Now here's where it gets fun. End behavior. End behavior I would hope would be pretty simple, but it's a lot more easy if you have a graph. So here's what I would suggest. Where have I already shown you that end behavior is going to match up with? Domain and range. So let's start off with the domain. In the domain, I have a negative infinity and a positive infinity. So I know one of the x's is going to be negative infinity. I know one of them is going to be positive infinity. That has to be there. And I know that one of the range, like for the y's, one of them is going to be a 7. One of them is going to be a positive infinity. I just don't know which one goes with which. Now, worst case scenario, you guess, and it's a 50-50 proposition. But we don't want to guess. Okay. So this is exponential. And more specifically, this is an exponential growth. And I know that an exponential growth has an asymptote up here. Normally, an exponential growth looks like this. That's how it would normally look. But this did undergo a y-axis reflection. So if I were to flip this over the y-axis, it would look like that. So which arrow is going to the asymptote? The left one or the right one? The right one is the one going to the asymptote. So the positive infinity is what gets the 7, and the negative infinity is what gets the positive infinity. The left arrow is going up. The right arrow is going down. What caused that is this y-axis reflection there. Jonathan, no, I see you squinting there. It's like you're thinking. It's a lot easier if you see the graph. I just try to kind of sketch a quick graph for you. The two main ways exponentials look before any type of a flip. This is a growth. That's a decay. This is when the base is greater than 1. This is when the base is between 0 and 1. Now he's got to figure out, did those flip and how many times did they flip and where did they flip? Same type of question, but now for logs. Let's start off with domain and range. What do we know about that for any log? Range is all real numbers. Todos los números verdaderos. What's the domain going to depend on? A vertical asymptote. Typically, all logs are to the right. So you'd be going from the asymptote to positive infinity, unless what specific type of flip would have had to have occurred? No, not x-axis. Yeah, a y-axis. If it has a vertical asymptote and I want to flip over to the other side, it would have to be a y-axis flip. Do I have a y-axis flip here? No, I do not, because C is just 1. So that means I'm going to stay to the right. Where is my asymptote? At -4, and I don't touch it, so oops. So parentheses -4, positive infinity. And behavior. If you want to try to narrow it down, I mean, I hope you know what you're doing, but at the very least, if you want to minimize, just take care of the x's already. If this is my domain, one of my arrows is going to be going towards the asymptote, which is at -4. One of them is going to be going to positive infinity with respect to the x-axis. But I got to figure out what's happening with the y's. Logs that have a base greater than 1. And this one has an asymptote at -4, which is like something like this. So typically logs look like that if the base is greater than 1. But since this one did not flip over the y, but it did flip over the x. So if I were to get this and either visually or just actually draw it again, if I were to flip this way, that's the way it would look. So which arrow, or better yet, the arrow that's going toward the asymptote, where else is it going? It's going up. So this is going to go with this, with a positive infinity, which would mean that this would have to go to negative infinity, and it does. When x goes to the right, we're also going down. Right, Edvin? I'll let Edvin handle the next one. What's the asymptote on number 14? Say it better. It's good. It's vertical because it's a log. X equals -2. Lydia, 15. What's the asymptote there? Good. It's exponential. Y equals -4. Now for number 16, which is the last one that we're going to do, this might be an oversimplification of things, but at the same time, I'm preparing you for really 2 multiple choice tests. What's the first multiple choice test you're going to get? What's the first multiple choice test you're going to get? The retake. I'm considering all the retake to be one big test. It's just split over 2 days. What's the second multiple choice test you're going to get? The midterm. The midterm is also multiple choice. So, you know, when we look at this is the type of problem that lends itself well to multiple choice, and just because it's multiple choice doesn't mean they make it easy. Like there's certain things that they could do to make this a little bit more challenging, but in this case they did not. What would I be looking at first? The asymptotes. Okay, I got 2 verticals and I got 2 horizontals, so that makes this is going to be a log, this is going to be an exponential, this is also exponential, and this is log. Now, if I wanted to, I would make all the asymptotes the same. If the asymptotes were the same, what's the next thing you should look for if you're just trying to recognize? It's the difference between what's called recall memory and recognize memory. If you're drawing the graph yourself, you're having to use your recall memory. You're having to remember how to do it and go through all the functions. Whereas here, when you're actually seeing the graph, all you have to do is recognize. What would be the next thing you'd want to recognize? Well, the asymptotes I would look at first, but what somebody that's clever, what they would do is make the asymptotes the same. Like watch here. Let's do the exponentials first. Okay. Out of these 2, clearly B and D are going to be the exponentials. Okay. But look at the asymptotes. One is -3 and one is at 1. If you were clever, what you would do is make them the same. So let's assume they were the same. What should you look at next? What will be the next clue that's not that hard to identify by looking at the graph? The reflections. I would look to see where should you be in regards to the asymptote. Okay, should you be above it? Should you be below it? Did a y-axis reflection occur as well? That's the second thing I would look for. But I don't even need to go that far. Let's see here on the top right, which we knew was going to be exponential. Where's that asymptote? It's at y equals 1. So that makes this D. That makes this B. Let's look at the logs. Okay, remember for logs, we find the asymptotes inside here. Where should the asymptote be for A? At +1. Which one has an asymptote at +1? Well, the top left. Yeah, so this would be A then. And then this would be, wait, did I put, oh, see here. No questions? All right, tomorrow you got your first 15 questions.